Anybody? You guys gonna be all right? A whole week next week, and then another 4-day week, and then a 1-day week before midterms. Yeah, one full week in January. You guys are rough lives. First world Delmar problems, right? Yep. All right, here we go. You remember CPCTC? It's got a cousin, CSSTP. All right. When we did CPCTC, that was after I proved the triangle's congruent, then any of their angles or sides were congruent. Now what we're going to do is, hey, if the triangles are similar, sides aren't congruent, they're what? Don't say similar. When two triangles are similar, their sides are 9? Proportional, and that's what we're going to prove. Everyone see the proof statement? Show the sides are in proportion. You can't do that unless you know the triangles are similar. So we're going to do that now. All right. Prove the triangle similar, then we'll say the sides are in proportion. Whoa. I see a couple triangles in this diagram, don't I? I see these two smaller ones. I see this big one here. There might be more I don't see now, but how am I going to figure out what triangles to prove similar? Because there's a couple. There's at least 3 in here that I could see. Any ideas how I can figure that? Because I don't want you to just pick 2. Oh, it's probably those 2. Got an idea, Spence?
The ones that correspond to the proof.
Look in the proof statement right now. Take a look at your proof statement. Everyone see CE? Here's CE. I believe CE belongs to one and only one triangle, doesn't it? This one right here. I don't see CE belonging to any other triangle. And then I look, DE. Well, I already highlighted that. All right, so let's keep going to find the second triangle. BE. Oh, here's BE. And that looks like it only belongs to triangle EBF. So I'm going to use your proof statement to find the 2 triangles to prove similar. And what's the only method? I know there's 3, but what's the only method we use in a proof to prove them similar? 11? Angle. All right, help me find 2 angles now. Help me find 2 angles. And the given said it was a parallelogram. Where are the 2 angles I can prove? At least, give me one pair right now. Probably go with the pair we're thinking about. 6. You're better than that, Nate Dogg, to give me that easy pair. You're better than that. But I'll take it. Angle DEC congruent to angle BEF. I'm still going to ask somebody why, because I don't want to hear reflexive anymore. Anna, why? Yep. Good midterm review here now. It is a parallelogram, so that's probably, they told us that for a reason. All right, so I have the verts here. Where else can I go here? 8, where else can I go here?
Angle A and angle C are congruent.
Okay.
They're opposite interior.
Where are you going with that now?
To get angle C and B congruent.
Okay, I see where you're going there because you're going to say they're corresponding. Okay, can we go right to C and B right now? What type of angles are those? You got it. Ready? I've got a couple hints here. Are they inside or outside?
They're alternate interior.
There we go. They're alternate interior. Whoa. Let's not write down quick. They're not congruent yet. I marked them congruent, but they're not congruent yet. I still need to tell you what. They're not congruent unless lines are parallel, right? Alternate interior angles are not congruent unless I know the lines are parallel. Which lines here? Which lines? And this is, hey, I'm going to give you guys a little tip here because I saw this in your quadrilateral unit when I was grading your tests and quizzes. You guys have a tough time figuring out what lines to show parallel to get the alternate interior angle. So you know what I'm going to tell you? Why not write, if you're ever concerned, write both. You can't go wrong, right? Write DC parallel to AB, DA parallel to CB, and you're not going to go wrong. Okay, so if you're ever concerned, what lines need to be parallel for those to be congruent? Who cares? Write both. Okay, write both. In this case, it's only DC parallel to AB, or you can write AF. Did you guys go over parts and extensions are parallel? Did you go over that when I was out? Extensions of parallel lines are parallel. Okay, that's fine. We'll just DC parallel to AB. Why are they parallel? Should know that part though. 3, why are they parallel, Spence?
Parallelogram implies opposite sides parallel.
There you go. Parallelogram implies opposite sides parallel. Now you can say the alternate interior angles. But again, if you are unsure if it's DC and AB or DA and CB, guys, write both. They're both true. Write both pair down. Can't go wrong. So now angle DCB congruent to angle CBF. And what do you got for me here? 1, what's my reason here, Anna?
Parallel lines imply alternate interior angles congruent.
Good. That's why I asked somebody. You got to have the parallel lines in there. Imply alternate interior angles congruent. Good work. Now I have angle. Somebody write me a good similarity statement now. Triangle. Can't copy it now from the proof statement, unfortunately. So name the first triangle any way you want and then match it up. 5.
Triangle ECD
EC is what?
or similar
Watch your mouth. Similar.
to EBF.
Yeah, that looks good. Make sure you guys write similar too, because I don't have any sympathy next Friday if you write congruent. Angle. And now we have one more step. Now we say, all right, now that the triangles are similar, corresponding sides are in proportion. And that is C, corresponding sides in similar triangles are proportional. CSSTP. Please don't write CPCTC. CSSTP. Corresponding sides, similar triangles are proportional. Anything? All right, one more here. I just wanted to expose you to something here. How about that proof statement right now? That's something we haven't seen, right? That is another way to write a proportion with the colon. Those are, do I have any English studs in here? Are those colons? Colons? No, that's not a colon, is it? Oh, that's a semicolon, right? Okay, all right. Sorry, that's why I'm here in the math department. Colons, all right? Written with the colons. This is another way. Hey, this is the same as FC over DB equals AC over PB. It's another way to write a proportion. Okay, another way to write it. All right, whoa. How many triangles do we see in this diagram? A ton. So let's figure out which two we got to prove similar. Ready? FC, everybody. FC. Take a look at FC. Is FC a side in one and only one triangle? Yeah, what triangle? FC A. So I think we found the first triangle. And then where's our second one? Let's see. FC to DB. Is DB a side in one and only one triangle? DB. DB. DBP. If it was a side in multiple triangles, I would keep just going on in the proportion. And then finally, I would find the two triangles I need to prove similar. All right, all good? Are we okay on finding the triangles? All right, now let's prove them similar. Given AB, these two are, AB congruent to AC, another little midterm review. And wow, altitude and perpendicular. I am just throwing everything I can at you here. Remember what an altitude was? All right, where's 1A of angle here? Where is 1A of angle? 12, one angle of angle. You got this. Come on.
Angle B.
Angle
B.
B and, well, that's in my yellow one here. And
An angle C.
I'm not a big fan of angle C, because which
Oh,
C are you
angle.
talking about?
ACF.
There we go. Those two right there. How does she know that? Angle B congruent to angle ACF or ACB. Why? Why those two? Ones, 11, why those two?
Because isosceles triangle combines hypotenuse.
This is isosceles, right? With these two sides congruent, what's across from two congruent sides? Two congruent angles. Good job, yeah. And you could say isosceles too, because it does say it's isosceles in a triangle. Congruent angles across from congruent sides. Where's the other pair then? We still have some more givens. We just used the isosceles triangle given. The other givens we haven't touched yet. That'll get us there. Where's the other A come from? 7, discussion. Come on, Kira.
DBP and
DB.
oh wait, BDP.
Yep.
And AFC because they're both right angles.
Good job. All right. Hey, I got a right angle here for some reason, and I got a right angle here for some reason. Like we did yesterday in the proof, hey, it's going to take 2 steps to say they're right angles because they're right angles for different reasons. I'm not going to put both in the same step. They're right angles for different reasons. So let's start with angle BDP is a right angle. Why? Why is BDP a right angle? Go look back at the givens. BDP was a right angle because 13.
Because it's an altitude.
Ooh, that's coming up. This was the altitude here. We're doing this one.
Oh,
So we got it from right here.
perpendicular lines.
There you go. Hopefully nobody heard you for the next one. Perpendicular lines form right angles. And then why is AFC a right angle then? AFC, yeah, AFC. 8, why is AFC a right angle?
Altitudes imply right angles.
Altitudes imply right angles. Definition of an altitude definitely would accept both. Again, would also accept definition of an altitude. Still got to say what about the 2 right angles though? 1, Anna, what do I still have to say about them?
That they're congruent.
Yeah, this will give me my second A. BDP congruent to AFC. All right angles congruent. I think you guys can finish it. Last thing I'll ask somebody, how about a good similarity statement now? Matching up all the angles. 12, how about a good similarity statement? Triangle, name it any way you want.
Triangle AFC.
Okay, hold on. AFC, go ahead.
Is similar
Good.
to triangle PDB.
That's a good one. Angle. And then you guys finish it off with the, now if you can write either, that's fine. You can write it with the colons or traditional. If you want to show off to your friends today at lunch. There you go, I use some colons. Feel all right? Oh, what's that you said? You want to do a hardcore algebra problem before we end class to the weekend? Yeah, you got it. You guys got it. Here we go. You got it. We can do a hardcore one. I know you're like, feed me early in the morning. I didn't have breakfast. Feed me hardcore algebra here. AB parallel to CD. Again, only reason we give you that shows the triangles are similar. Sides are in proportion. All right, you guys did a lot of work yesterday in class and on homework. Great questions last night you guys had on the homework. Let's match up. Can we match them up here? Give me a side from the small triangle. Let's start out. 8, give me a side.
X minus 1.
All right, great. We're going hardcore right away. Not going for the simple one. AF matches up with what side? Don't give me the side length, just give me the name. FA matches up with 11.
FC.
FC, everyone ready? I always do this, but you don't have to. FC is x minus 1 along with 2, and I got to add them together, not multiply them, add them together. Combine your like terms. How long's FC? 11 again, FC.
X minus 1.
There we go, x.
Plus 1.
There we go, boom. All good? All right, what about the other two then? Can you match up the other two sides real quick for me? 4?
4 over x plus
7? Where'd 7 come from?
x plus 3.
Yeah, there's nothing to combine, right? It's just this side corresponds with this side, x plus 3. Everyone all right? Again, you guys know that's half the battle is getting the correct proportion. You good here, boss?
Yeah.
You sure?
Yeah.
Did you put 7 down too?
I did, yeah.
Where's 7 come from? You guys add it to the 4?
Yeah.
But it's not the thing, it's not like broken up into x plus 3 and 4 like that.
Yeah,
It's just x plus 3, right? I wonder about you sometimes. All right, ready to cross multiply? Good. Somebody cross multiply and tell me what I get on both sides of the equal sign right now. Just cross multiply. Ooh, double distribute. Never mind. 4x plus 4. Oh, yeah, a little double distribute here. FOIL. Go ahead. I wasn't joking when I said it was hardcore. Can you let me know? I want combine like terms and everything. What do you get when you ended up double distributing? X squared. What else do you have? Combine everything for me too. 10. X squared.
X squared. Plus 2x.
You got it. And then minus.
3.
Good. All right, you guys know the deal, right? Get one side equal to 0. Go ahead. 0 equals x squared. I'll ask for the rest here in a second. Uh, 10 again. What's the rest when I move everything over?
X to the second.
Yep.
Minus 2x minus 7.
Nice job. Good. Now, everything we've done so far, you're probably going to do this, right? Boom, 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 boom. Let's find two numbers that multiply to what? 7 and add to -2. I'll wait. All right, let's stop the funny business. There are no numbers, right? There are no numbers. So we're not going to be able to factor this. What's the only other option I have if I can't factor to solve? Quadratic formula. Stop. Everybody stop. There was a way we could have already predicted before we started this problem that we were going to use quadratic formula. Before we even wrote down this proportion, we knew eventually we were going to have to hit quadratic formula. Anybody see our hint anywhere that would set up quadratic formula time?
It says the value of x in simplest radical.
Everyone see that? We've never factored anything and we're left with a radical, right? So that tells you in the directions, hey, I'm going to use quadratic formula sooner or later down the road. So watch out for that. All right, watch out for that in the directions. If you say leave your answer in simplest radical form, it's going to be quadratic formula time. All right, so just a reminder, x equals negative b plus or minus square root b squared minus 4ac all over 2a. I'll give that to you next Friday. No need to memorize. Can somebody give me the a, the b, and the c value from our quadratic here? What's the a, the b, and the c? 10 again, on fire.
A is 1.
Yep,
B is -2. And C is -7.
good job. All right, let's plug her in. Negative b. What do we plug in for negative b? 12, negative b, it'll be
Positive 2.
good. 2 plus or minus. You know how I roll here. Parenthesis time. Parenthesis time. Negative 2 squared in parentheses minus 4 times 1 in parentheses times negative 7 in parentheses. All over 2 times 1. Get the number underneath the radical now. Because remember, it's its simplest radical form, so I may need to break it down. When you get it, let me know. What's the number you get just the number underneath the radical? 11 when you get it? 20? You sure? You put parentheses in your calculator? Negative 2 squared minus 4 plus 1 times negative 7. Try it again.
That's what I put.
Negative 24?
Oh, 28.
28, there we go. So we 28. Oh, I still didn't get 28. This gives you 28, but then we got 4 over here. Try it one more time, Kelsey. I just want to make sure because you're going to have to do it tonight for me.
4 minus 20. Because 2x squared. 4.
Okay, read in your calculator. Parenthesis, negative 2, close it, squared. Good. Minus 4, parenthesis 1, parenthesis negative 7. There you go. Okay, make sure we type the whole thing in with the parentheses. Everyone 32 on their calculator. Nate Dog, you get 32? Okay. Anybody else? We good? Okay, all over 2. All right, go ahead. Break down off to the side. 32. Biggest one, not the first one you come across. Biggest perfect square that goes into 32. 4 is not the biggest, FYI. There's more. There's more. 11 again, Kelsey, redemption time when you find it.
16 and 2.
There you go. 16 and 2. So it breaks up into 4 radical 2. Replace it. Replace it now. X equals 2 plus or minus 4 radical 2 over 2. And now I want you to break it up into 2 fractions now to reduce. 2 fractions. Ready? 2 over 2. I take the left side of that plus or minus. 2 over 2. Plus or minus. Take the right side of the plus or minus. 4 radical 2 over 2. Break it up into 2 fractions. Reduce what you can here. Kelsey, again, 11. 2 over 2.
1.
Yep. Plus or minus, what reduces here?
4.
Yep. So you end up with?
2. Radical 2.
Don't you dare, Nate Dog. Put that back. There you go. We're going to have an awkward staring contest till somebody tells me what the deal is here. Sure about this? Go ahead, speak.
Yeah, why not? You said one for plus, another one for minus.
You don't have to. You can leave it plus or minus. You don't need to show me both answers.
Just leave it there.
Grab your calculator. Okay, grab your calculator. This is 2 answers, isn't it? Abbott was just saying this is two answers. What's one of the answers written out? Write one of the answers out for me. 8, 1. I want to split these up into the two answers that they are.
1 plus 2 radical 2
And?
and 1 minus 2 radical 2.
Okay. Everyone type in your calculator 1 minus 2 radical 2. Anybody see the problem?
Negative.
I plug that number in right here. What's going to happen? What am I going to get here? I'm going to get a negative side. Everyone see that? So even though we're not factoring, we still have to watch out to reject an answer. All right? We still have to reject this answer here. This is why it's going to end up being tough. We cannot have this. There's only one answer here. So even when we do quadratic formula, we got to look to reject. Questions? Okay, flip over your assignment here. I just want to make sure we're good. Everyone see the directions on number 1 to the nearest 10th? Probably what you're going to end up using here. Quadratic formula. How do you leave it to the nearest 10th? See what we just did up here? Break up your answer into 2, type it into your calculator, and round to the nearest 10th. If you have to reject one of them, reject one of them. Okay, so that's how you round to the nearest 10th. Separate them, find the decimal, round. All right, you're on your own. Some of you guys